Oh yes, friends, you are most welcome once again to the eMath learning platform. It is still your teacher Peter Ekajja. I would like by thanking all my friends out there, all the learners out there who have subscribed to my channel, and I still encourage that we share this content. We need to share this content out there. Let's help those who are in need out there. Even if you don't believe in mathematics, even if you don't enjoy mathematics, please look out for someone you can share this content out there so that we help our country and the world at large. Now, this time round, I am bringing you another technique of integration, and specifically, we are going to be integrating by changing the variable. When we talk about changing the variable, it is a method that actually can be employed in various integrals, as we are going to be seeing in the following examples. Now, for today, we are only going to look at those examples where at least a function exists with its derivative within our function that we're integrating. So we shall look at such functions, then later on we shall also still use the same method to integrate functions whereby the function may not necessarily appear together with its derivative. Now, without wasting a lot of time, let's look at the following examples. So we are saying find the following integrals. Part A, integral of x into 3x squared plus 2 power 4 with respect to x. Part B, integral of x into x squared plus 5 power 6 with respect to x. Part C, integral of x out of square root of x squared minus 1 with respect to x. Part D, integral of 3x squared minus 1 divided by square root of x cubed minus x plus 4 with respect to x. So remember, we have to be with the respect to x here. We shall have dx here. An integral cannot be valid not until you have the respect of integration. Yes, there we go. Now we also have part F, which is that integral, part G, which is that integral. We are basically going to begin with part A of our question. Now we shall realize something very common about all these integrals in this case. Let's look at part A. We have x into brackets x squared, 3x squared plus 2 power 4 with respect to x. Now when you look at this function, it is a product of two functions, but we must appreciate the fact that when you differentiate whatever is within this bracket here, that is 3x squared plus 2, you're going to come up with 6x. Now the 6x will contain the element of x. Because it contains the element of x, then that would help us to cancel out this x here, that is after making the x the subject, as we are going to see. So that is something very important, very important in that case. So we can now say that we are letting u to be 3x squared plus 2. Now if u is 3x squared plus 2, the next step is going to be looking for du dx. So du dx will be 6x plus 0. Remember, when you differentiate 2 with respect to x, you get 0. Now after obtaining du dx, we simply go on and get the value of dx in terms of x and then du. So it means we simply make dx the subject, so that we have du out of 6x. Now that our dx is that, we can say integral of x into brackets 3x squared plus 2 power 4 with respect to x is the same as integral of x u power 4 du out of 6x. What has happened here? What has happened here is simply that the 3x squared plus 2 was already called u in this case. We already called it u. Then the dx, we made it the subject in this case. So we came up with du out of 6x. So we have replaced 3x squared plus 2 with u, but remember there was a power. There was a power, so we maintain the power there. Then we have replaced the x with the du out of 6x. When you look at this carefully, this x automatically will cancel with this x here. So if those cancel off, it means we shall now have to remain with integral of u power 4 out of 6 with respect to u. But because 1 over 6 is a constant, it can come out of the integral sign. And remember, when you integrate u power 4 now with respect to u, you simply increase the power by 1 divided by the new power. That is why we have u power 5 divided by 5 plus our constant c of integration. Now when you multiply this by this, you get 1 out of 30 u power 5 plus a c. But remember, we now have to go back and bring the value of u in terms of x, which is 3x squared plus 2. So we shall substitute for u back, and that gives us our solution as integral of x into 3x squared plus 2 power 4 with respect to x equals to 1 out of 30 into brackets 3x squared plus 2 power 5 plus a constant, and that becomes our answer for that specific integral. Question B, we had integral of x into brackets x squared plus 5 power 6 with respect to x. Again, when you look at this carefully, when we differentiate what is within the bracket, it will give us 2x. Because 2x is our result, it contains the element of x. So it means the best choice would be that we shall keep this power, then we maintain it as we move on with our integration. So the best choice here is to let our new variable, which I'm going to use as u, to be x squared plus 5. When I do that, I will now look for du dx, and du dx becomes 2x. I make the x the subject. It becomes du out of 2x. After doing that, we automatically go for the substitution. So we shall say integral of x into brackets x squared plus 5 power 6 with respect to x is equals integral of x u power 6 du dx. I mean du out of 2x. Why are we saying this? Again, you need to recall that we called x squared plus 5 u. That is why we have a u here. But remember, we had a power here, power 6. That is why we have power 6 here. The x, we just made it the subject, and it became the u out of 2x. When you look at this again, the x here will cancel with the x there. So it means the next integral will be now a half integral of u power 6 with respect to u. And when you integrate that, you simply increase the power by 1, divide by the new power. When you do that, our final answer now is going to be 1 out of 14, because we are going to multiply this by this. So it will be 1 out of 14. Where there is u, we substitute back the x squared plus 5 power 7 plus our constant of integration. So this is how easy it is to use the change of variable method. But make sure you use a better choice that helps you do away with the old variable, then you move in for the new variable. For example, when you look back here, we made sure x cancelled completely, and whatever we remained with was in terms of u, and the respect of integration was u. So you really need to make sure that happens. If you reach a point where x insists, then it means you really can't proceed unless if you expressed x in terms of u. Okay, now let's move on to our next example. I'll give quite many examples in this case because guys have to really perfect on that. So we have this integral of x out of square root of x squared minus 1 with respect to x. Now when we have this, when we have this, then this time around the choice again matters. You're going to realize that when someone lets u or lets p or any other variable of your choice to be what we have in this square root here, if I let u to be x squared minus 1, when I differentiate x squared minus 1, it gives me 2x, but 2x contains the element of x that we have here. So it will also help us cancel out the x, and that will be a better choice to take. So it means we shall simply say let u equal to x squared minus 1. We look for du dx, which is going to be 2x. We make dx the subject, that is du out of 2x. After that, we now go back and do the substitution. So integral of x out of square root of x squared minus 1 with respect to x is equals to integral of x out of square root of u, then du out of 2x. What has happened here again is that we had the whole of this x squared minus 1 as u. So being u now, that is why we have a u here. We had the x being the same as du out of 2x. That is why now the dx has been replaced by the whole of du out of 2x. Again, we can see that this x can cancel with that x. So if that happens, we remain with 1 out of u. There is also a half there. Then we are integrating all that with respect to u. So it means we shall now have a half out, because a half is a constant, then integral of 1 out of square root of u with respect to u. After this, now we know that 1 over square root of u is the same as 1 over u power half, but 1 over u power half is the same as u power negative a half. So I'll say a half integral of u power negative a half with respect to u. When you're integrating this, we can again increase the power by 1, divide by the new power. So it means we shall have a half into brackets 2u power a half plus our constant. Now what has happened here is that we have increased this power negative a half. We have added a 1 to it. So negative a half plus 1, you get a half. So it means our integral becomes u power half divided by a half. But u power half divided by a half is the same as u power half times 2 out of 1, which is the reciprocal. Now this 2 can help us and cancels with this 2, so that now we have u power half, but you remember that u power half is as good as the square root of u. But now our u originally was x squared minus 1. So it means our result here is going to be square root of x squared minus 1, but plus a constant of integration. And that becomes our answer for that. Let's move on to part D of our question. Let's look at part D. We have that integral 3x squared minus 1 out of square root of x cubed minus x plus 4 with respect to x. Now that we have this integral, again you have to think critically. You're going to realize again that when you let u to be x cubed minus x plus 4, which is within our square root, when you differentiate it, you will get 3x squared minus 1, which is up here. So that becomes still a better choice to take, and therefore it will help us to cancel out the 3x squared minus 1 at some point. So what shall we do? We shall say let u equal to x cubed minus x plus 4. Then we get du dx. Du dx becomes 3x squared minus 1. Make dx the subject, it becomes du out of 3x squared minus 1. Go back for the substitution. Now we go back and have the whole of this integral, and we shall say integral of 3x squared minus 1 out of square root of x cubed minus x plus 4 with respect to x is equals to integral of 3x squared minus 1 out of square root of u, and dx becomes du out of 3x squared minus 1. Again, the good news here is that this 3x squared minus 1 can now cancel out with that. So that will remain with only du here. Then we have 1 over u here. I mean 1 over square root of u, which can now easily be integrated. So it means we shall have the square root of 1 out of, integral of 1 out of square root of u with respect to u. But 1 out of square root of u, we already said, is the same as u power negative a half. So we are integrating with respect to u again. Increasing the power by 1 and dividing by the new power will give us 2u power half plus a constant. But what is our u? We substitute it back in terms of x. So it means we have integral of 3x squared minus 1 out of x cubed minus x plus 4 with respect to x equals to 2 integral of x cubed minus x plus 4. The square root came because of power a half. It came because of power a half, and that is our answer. Let's move on to the next integral. So in the next integral, we have now brought in trigonometrical functions. When you look at this, you now need to think critically and carefully, because again I see that here we have sine x but squared. Because of the square, it is going to now be tricky if we don't let u to be only sine x, because you can first ignore the square, so that when you differentiate sine x alone, it actually gives you cos of x. So it means the best approach or the most suitable substitution will be letting u to be our sine x. Now remember, I have used u very many times. You can use any other variable of your choice. I have used u and I will maintain it for all my questions, but you can use any other. So if u is sine of x, du dx, remember when you differentiate sine of x, you get cos x. Make dx the subject, it becomes du out of cos x. After that, go and bring your integral and do the substitutions. So when we do the substitutions, it will be integral of cos x, then u squared du out of cos x. What has happened again is that our sine x was called du. Our dx has now become du out of cos x, so we have made those substitutions. Again, you can realize that cos x can now cancel with cos x. If that happens, we remain with integral of u squared with respect to u. So it means shall now have integral of u squared with respect to u. I beg your pardon here. Before we continue with that, this must be du, not dx. So we have to make sure this is du. Remember, we moved away from x, so this must strictly be du. We cannot have the x again because we already substituted for it. So that is going to be x squared du. And when you integrate this, you will get u cubed out of 3, which can be written as a third u cubed plus what? Plus c. Then now in conclusion, we shall say integral of cos x sine squared x dx is equals to a third sine cubed of x plus a constant. Take note of that, what we have just adjusted here. Make sure it is u and not x. Good. Let's continue to part f. We have integral of sine x square root of cos x with respect to x. Now this is where it becomes a little bit tricky and you have to think hard. You need to remember now that where we have a power, and this time round a funny power, which is power half, we have to really give it attention, so that now when you still let u to be your cos of x, you know that when you differentiate cos of x, it gives you negative sine of x. So it will help us to still cancel this x, sine x here. It will still help us. You cannot let u to be sine x because it cannot cancel this cos x with its square root. No way. So we shall prefer taking what is within the square root. We let it to be u, differentiate it so that it helps us cancel the sine x at some stage. So there we are. Now let's look at what is going to happen there. Shall say let u equal to cos x. Du dx becomes negative sine x. The x becomes du out of negative sine x. I now go back for the substitution. So I will say integral of sine x square root of cos x with respect to x is equals integral of sine x square root of u, but the x is du out of negative sine x. The good news again is that now the sine x and the sine x have cancelled off. We remain with integral of root u, but with respect to u. So it means we have perfectly changed the variable. So in such a way, we can now conclude that our integral will be a negative one, but of u power a half with respect to u. And when you integrate that, you maintain the negative, it will be 2 out of 3 u power 3 out of 2. What happened exactly is we had negative integral of u power half. Increasing a half by 1, you get 3 out of 2. Then so you divide by the new power, which is 3 out of 2. But dividing by a new power, which is 3 out of 2, is as good as multiplying by the reciprocal, which is 2 over 3. We now substitute for what our u is in terms of x. And the answer in that case comes to negative 2 out of 3. Cos of x, 3 out of 2, but plus a constant. Remember, this 3 out of 2 is the power of cos of x, remember. Or someone could say from 3 out of 2 we can have a half out, and a half is as good as a square root. So someone can conclude by saying integral of sine x cos of x with respect to x is the same as negative 2 out of 3 square root of cos cubed of x plus a constant. Please, these two results, this and this, are mathematically the same, so no worry about it. Okay, now we can move on to our next example, and that is part D. We now have sine squared of 4x cos of 4x with respect to x. Again, like I said, the best choice here is going to be looking at where we have a power, but we only take that function and we first pair its power. When you differentiate sine of 4x, you will get 4 cos of 4x. So at least the element of cos 4x comes in, and so it will help us cancel it. So now it means that we shall say let u equal to sine 4x. Du dx will become 4 cos of 4x. Dx alone becomes du out of 4 cos of 4x. And then we go for the substitution. When you now do the substitution, that integral that we have becomes integral of cos of 4x into u squared, but dx has become du out of 4 cos of 4x. The cos of 4x again, as you see, cos of 4x can cancel with cos of 4x, but keep the work smart. So I will have that, and I remain with a quarter integral of u squared. So if you integrate u squared, you get u power 3 out of 2, but a third and a quarter gives us 1 out of 12. Then our u cubed plus a constant. But what is our u? Our u was, remember, sine of 4x. So we shall make a conclusion that integral we have is 1 out of 12, sine cubed of 4x plus a constant. Now this brings us to our last example for this specific tutorial, but next time, in our next tutorial, we shall now integrate functions whereby the derivative may not necessarily appear, but still using the same method, that is changing the variable. I thank you so much. Keep sharing these videos, keep subscribing until we hit the 1,000+ subscribers. Thank you so much, and see you again in our next tutorial.